This video brief is about Orbital Bridge, a project to make low-cost, high-volume transport of materials into Earth orbit a reality. Low cost means less than $300 per kilo of mass. High volume means up to 70,000 metric tons of cargo per year per launch facility. All of this can be done using only renewables and with zero carbon footprint. For the past 60 years, the full promise of a true space age has remained elusive. Even so, there is no denying that the space industry is growing, as evidenced by plans for a variety of significant missions being shared with the public. Orbital bases, colonies on the Moon, robotic asteroid mining, inhabited bases on Mars, long-range manned missions throughout the solar system, space tourism, and so much more. All of these plans and visions are laudatory, but unfortunately, they are just not feasible at scale with today's technology. It is simply too expensive to lift materials into orbit, the amount that can be lifted over a calendar year far too limited, and the environmental impact of launching too great. If we are to have a legitimate path to our goals, we must have a new solution to lift mass in much higher volumes at much lower costs with negligible environmental impact. Orbital Bridge proposes to be that solution. The main patent for the launch system comprises devices, apparatus, and methodology for launching durable cargo into Earth orbit at an industrial scale, operating 24/7 year-round by means of a specially designed reusable spaceplane launch vehicle that is accelerated to hypersonic speeds horizontally while attached to a magnetic levitation linear accelerated sled at near sea level atmospheric pressure. The heat energy from the hypersonic thermal shock wave is directed close to the leading edges of the nose and wing areas, and the energy from the shock wave is scavenged by thermal shielding that both protects the craft internals and transmits that heat energy through an internal heat pump configuration to an internal boil chamber. There, a distilled supercritical water payload is converted into 1,000 degrees super high pressure steam, which provides thrust to continue to accelerate the spaceplane launch vehicle long after it has left the maglev acceleration system. Using adjustable flight surfaces and an actuated rocket nozzle, both controlled by an autonomous integrated flight computer, the SPLV will adjust the pitch angle to an appropriate escape vector depending on program destination. Using a combination of fuel payload, boiler chamber size, initial accelerated takeoff velocity, and other configurations, a wide variety of orbits can be attained. Once orbit is achieved, a traditional orbit maneuvering system using hypergolic liquid propellant rocket engines will be used. It will be used for orbital injection after main steam rocket cutoff, orbital corrections during flight, and final deorbit burn for re-entry. The SPLV lands like a seaplane on the water without landing gear, and, being empty of cargo and fuel, is designed to float. After recovery by ship, it will be taken back to the launch facility to be refurbished for the next flight. Included in the Orbital Bridge project are system, methods, and devices for managing cargo. Prefabricated cargo modules with copious hard spots for handling and linking modules together will make transporting cargo in space much more efficient, especially when dealing with a variety of different customers. If it fits, it ships is the tagline for USPS Priority Mail flat rate boxes, but it is equally applicable to the Orbital Bridge cargo module. If it can fit into a 2-meter high, 2.6 meter diameter cargo module, can be load balanced, and weighs under 2,000 kilos, it can go into space with Orbital Bridge. Using modular design and assembly in orbit, larger structures can be built. For unloading cargo modules, reloading empty modules back into an SPLV, and for moving cargo modules around locally, Orbital Bridge will develop a cargo tender, which will be an autonomous space robot with thrusters that will have easy-to-load fuel cells, manipulator arms, and a broad array of sensors. The other autonomous craft that will be created is called a heavy tug, and it will move chains of connected cargo modules to different orbits or further out with additional fuel modules.